Grade 11, this side, I'm going to take you through the basics of probability. So for inclusive events, the probability of A or B is equals to the probability of A plus the probability of B subtracts the intersection of A and B. For inclusive events, the intersection of A and B should not be equals to 0, since A and B share the same element. As for exclusive events, the probability of A or B, you could also write this as A or B. So the probability of A or B is equal to the probability of A plus the probability of B minus their intersection. So as for exclusive events, the intersection of A and B should be equals to 0, since A and B do not have anything in common. They do not share common element. So moving forward, event A and B are exhaustive. Event A and B are exhaustive if the probability of A or B is equals to 1. If the probability of A or B is equals to 1, suppose you have this Venn diagram, F7 here, 3, 4, 2, 1, you have A and B. This is for exhaustive events, since A or B contains all the elements in the sample space. However, A or B is not equals to 1 if you have A and B, maybe a 3, 6, 1, 2, and you have 4 here. Since A or B do not contain all the elements in the sample space, then they are not exhaustive. They are only exhaustive if A or B contains all the elements of the sample space. Moving forward, as for complementary events, the probability of not A plus the probability of A will always be 1. And from here we get the probability of A equals to 1 minus probability of not A. So here is an example. In a random experiment, it was found that the probability of A, given the probability of A is equals to 0.25, the probability of B is equals to 0.5, and the probability of A or B is equals to 0.625. First question is calculate the probability of A and B, and the second question is determine with reasons if A and B, determine if A and B mutually exclusive, inclusive, complementary. So as for A, how do you go about answering A? As for A, if you wanna calculate the probability of A and B, student would go and do this: probability of A multiplied by probability of B. This is not correct since you were not told that A and B are independent. So this wouldn't be correct. So the correct approach would be the probability of A or B is equals to the probability of A plus the probability of B minus probability of A and B. Now you're solving for this part. You're solving for this part because A or B you were given, the probability of A you were given, the probability of B you were given, and then you plug in. So as for this, you have 0.625 is equal to probability of A is equal to 0.25 plus probability of B is 0.5. Subtract the probability of A and B, the one that you're looking for. So you can either take probability of A and B across and take 0.625 this side on your right hand side, or sum these and take them across. So I just take B this side, the probability of A and B would be equals to, this is 0.25 plus 0.5. This will be 0.75 minus 0.625. So the probability of A and B is equals to 0.75 minus 0.625. And then you get 0.125 as your answer. And then B, determine if A and B are mutually exclusive, inclusive, complementary. As for B1, are they mutually exclusive? No, they are not. Why? Because they do have probability of A and B. They do have the common element, so it would be no. Number two, inclusive. Yes, they are inclusive since probability of A and B exist. So it exists. They do share the same element. So it's like this. So yes, it's inclusive. Number three, complementary.